Good day, great souls. Welcome back to your lesson 5. And in this lesson, boys and girls, we'll be talking about sigma notation and a series. Now, boys and girls, I want us to first talk and think back to maths. When we say we sum something, boys and girls, in math, we usually imply that we're adding on top of each other, right? And this is essentially what sum is in this topic. Now, sum is the result of an addition. Simple, straightforward. Now, boys and girls, we have what we call now a series. Now, boys and girls, what is a series? When something is in series, think back to physics. When something is in series, something is usually next to each other. And when you think back to physics, that's if you take physics. I just want to use this example. When we add the total, when we add, for example, the total resistance in a circuit in physics, and the circuit and the resistors are in series, boys and girls, we would add the resistance of each and every circuit, of each and every resistor, we'd add the value of the resistance of each and every resistor in the circuit. Now, this is essentially what's happening in this topic. A series, we keep adding. So now, boys and girls, for example, we could have 1 plus 2, or let's just say 1 for 1 plus 3 plus 5 and plus 7. Now we could see that this is arithmetic because we're adding 2 each and every time. But this is not an arithmetic sequence, boys and girls. This is to be considered an arithmetic series. It's in series. Why is it in series? Because we're continuously adding. And the easiest way, boys and girls, if you take something from what I'm saying, the easiest way for us to know that something is a series, it's usually represented by a plus or minus sign. And the easiest way for us to know something is a sequence, the semicolon. So semicolon, sequence, plus or minus, series. Right, boys and girls? All right. Now, as we see, series is the sum of a sequence, right? The sum of a sequence. So we'll have a sequence and we're adding and adding and adding and adding and adding that series. Now, sigma notation. Boys and girls, sigma notation is represented by this little sign that is almost identical to an E. And this is the sign that basically represents sigma notation. So, in layman's terms, boys and girls, when will we be using sigma notation? Sigma notation will be used when you'd be asked to write a certain sequence or a certain arithmetic series or geometric series in sigma notation. And there's a formula to this, boys and girls. This is very, very easy. If we happen to then follow the format that I've given you. And boys and girls, as we can see, we'll have our sigma sign, and next to the sigma sign, we'll have our brackets. And in those brackets, boys and girls, what will we be doing? We will be putting in our formula that describes the arithmetic series or the arithmetic or the geometric series. Okay. All right. And then from the bottom, at the bottom of your sign, boys and girls, just get this pen to work. The start at the bottom of a sign what's this called again? At the bottom of your sigma, you will be writing the position where you start. So it could be, for example, let's say we have our sigma here. Let's say our formula is 7n plus 1, right? Now, and then for example, this series starts in the first term. N would be equal to 1. It can also start at the second term. N is equal to 2. Okay. And then, boys and girls, when we move on to the top represents the term at which we stop. For example, a sequence ends at the number, at the total of, like, for example, 600. And then from there on, we want to find, and the number 600 is the last term, and we want to find out what is the value of the term. What position is that 600 in? We find that, we solve for n, as I've taught you in prior videos, and that specific term, that last term, for example, we might be ending that the sequence or the series might have 16, what's this called again, might have 16 terms. Then we write 16 here because we ended at the 16th term. Okay, boys and girls. Now I want us to continue. I wrote you very important. It is very important to obtain the number of terms from a sequence or series that has been given to us in sigma form. We would say the top minus the bottom. The top minus the bottom. And we'll get there. Okay. For example, boys and girls, in this example, you're asked to calculate this whole sequence. And we see here, we start at the second term, we end at the 8th term, and also we have the formula given here. So it asks us to calculate. So how would we calculate this? We will calculate this by doing the following, boys and girls. When you see an I, you substitute first the number you start at. Okay. So for example, our formula is 4i. So where I see an I, I'm going to first put a 2 minus 1 plus. Okay. Because this is the sum of. The sum of. Sigma represents the sum of. So we're dealing with a series. Sigma represents the sum of. I hope I'm making sense, boys and girls. I'm quickly going to carry on here. So I'm going to start. So it's 4 multiplied by, because we're starting at 2 minus 1 plus 4. Then we carry on. 3 minus 1 plus 4 minus 1 plus 4 5 minus 1 plus 4 6 minus 1 plus 4 7 minus 1 plus 4 8 minus 1. And this gives us a total. This, you just plug it into your calculator and it should give you a total. Okay, so essentially that is how you would solve a question. I know it's very tedious, but we will get to a point whereby I'm going to give you a formula and you could easily solve this. So boys and girls, you are likely never going to have to solve this by yourself, whereby you open up brackets and substitute into the formula and have to spend a rigorous amount of time putting this into your calculator, and the total is 133. So the sum of this series from 2 to 8, from the second term to the 8th term, is 133 when I plug it into my calculator. Now, boys and girls, moving on. We're moving on. It says write the series in sigma notation. Sigma notation. So that means we'll have the sum of n is equal to, and then this is where we stop, and this is our formula. But first, what do we need? We need to find our formula. We need to find out what term this is, and then from there on, we'll be able to move accordingly. So we're given the sequence 3 plus 6 plus 12, 6 plus 12. Okay, let's see. So from there to there, we're adding 3 now. So that we can see that automatically this is a arithmetic sequence. Why can we see that it's an arithmetic sequence? Because 12 divided by 6 is 2. 6 divided by 2, 6 divided by 3 is also 2. Plus, all ending at 6,144. So boys and girls, I want us to get our formula. We said that this is an geometric series, right? And we said that our geometric series, boys and girls, is defined as a r n minus 1. So our first term, boys and girls, as we can see here, is 3. We plug that in. Our r, as we said, our r is found by t2 over t1, which is equal to 6 over 3, which is equal to 2. So r is equal to 2 n minus 1. Now let's find out what term this is, because we require where we start. We said we start in the first term, and we require where we end. So we don't know where we end, but we do know that the last term has the value of 6,144. So 6,144, boys and girls, is equal to 3 multiplied by 2 n minus 1. Alrighty. Now 6,144 divided by 3. So we divide both sides by 3, boys and girls. When we divide both sides by 3, we get 2,048. And then we'll have 2 n minus 1. So boys and girls, what we do then is we'd find a way in which we could write 2048 in such a way in which 2048 in such a way in which we are basically getting the bases the same. Okay, so we want to get the bases the same. So what would in a normal case give you 2044. Let's see. So 2 to the power of what gives you 2044? If I plug it into my calculator, you guys should know it by now how to get this easily. So 2 to the power of 2 to the power one second, 2 to the power of Yep, 2 to the power of 11 is the same as 2 to the power of n minus 1. So when the bases are the same, remember your laws of exponents. 11 is equal to n minus 1. We add 1, we add 1. N is equal to 12. So this is where we stop, boys and girls. This is the position of our last term. So now we have to answer the question. The question asks us to write this in sigma notation. So we started with our n, the value of our n here. We started first from the first term. Fine. And then the formula of our sequence is, as we've seen, 3 multiplied by 2 n minus 1, and we ended at the last term, which is 12, t12. And that's how you solve it. I hope I'm making sense, boys and girls. Don't be afraid to let me know whether I've lost you and where I've lost you, and I don't mind clarifying certain questions. Okay, boys and girls. Now, boys and girls, I want us to then move on to getting an easier way. Getting an easier way from this, because you might be given something in sigma notation and then you're like, solve it. Are you going to go through the long and tedious way? No, you're not going to use the long and tedious route, but rather, we always have a formula for everything because we care about you guys to a certain point. To a certain point. Now, boys and girls, I want us to quickly start with this. It says, summing a large number of terms